Okay, class, today I'm going to do a little lab here, lab 2-1 series circuits current relationships. I've got a lab volt bench here set up. I've got a couple fluke meters that I'm going to utilize. Now, if we were doing this in person in class, we would be asking that you guys as students to be operating the analog meters in order to get a little bit of better meter practice. The only reason I've chosen to do the digital meters is because it's a bit easier for us to display the information that the lab is going to capture. Important to note that because we're using a DC source, if we're using analog or digital, we need to make sure that we're observing the meter connections correctly for polarity, as well as if they're in series or in parallel. If they're analog meters, very much more sensitive to polarities. Obviously, we don't ever want the meters to be moving downscale. We always want them to be moving upscale. Whereas a digital meter, it's just going to give us an opposite polarity if I've improperly connected it. Okay, so for this lab, we've got three cone heaters connected up top here. I've got, if you look at the diagram in your lab book, they asked us to connect those three cone heaters in series, and then they've also asked us to connect up a voltmeter in parallel with the source, which I have here, and an ammeter in series with the loads. And what we're going to do is we're going to move this ammeter around throughout this lab in order to ensure that the current is maintained through the entire circuit. That's what we would expect to have happen. So the procedure, we've got the main breaker off. I've connected everything up. Okay, then in step number 5 here, they ask us to turn on the power here and slowly energize this, the power supply up to 120 volts DC. So we'll see if we can get up near that. We're at 85, 90, 100, 115, 120. And we've got a current value here of 1.9 amps. I'm just going to see if I can zoom in a little bit here. Pardon me. On what is happening with those meters. Okay, so 1.9 amps, current is flowing through this circuit completely. I'll zoom out a bit. I will show you what I'm going to do next as far as the connections. So the next step, we're going to power down. I've left the supply at the same value there. Just that way when I power back up again, it's going to be exactly the same. And then they want me to move my ammeter, which was in this first position. Okay, so I'm going to take this lead out. I'm now going to have it connect up to my cone heater at the top there. Sorry, I guess I can tilt it up a little bit so we can see the whole lab. Okay, and then what we want to do is we want to interrupt this lead here. Okay, so this is my positive lead, making this my negative. Okay, so I want to make sure that my negative is going into that guy. Okay, and then my positive lead from that ammeter is going to be connected up into the next one. So now our current flow here is going to be coming out of the source, well actually sorry, out of the negative, through this cone heater, through that next cone heater, jumping through down to the ammeter and then back up, and then coming and returning back. Okay, so I'm just going to power up, and we anticipate the current. Oh, you can see I've got my meter polarity opposite here. It's negative there. So what I should do is I'm just going to flip that around. And now we will power up, and you can see we have correct polarity there. We've got 1.9 amps of current flowing there again in step 2. So next one, all we're going to do is we're just going to power down. I'm just going to shift these meter leads over to this next spot. Okay, and then I will power back up again. Okay, and once again we've got that same level of current of 1.9 amps. I'll power down. I am then going to interrupt my negative feed. So this is my negative coming to my common of my meter. My positive is up here. And we need to then, whoops, sorry, no, that would put it in parallel. That's gone. and then we'll replace this jumper here. Okay, and we've got 1.9 amps once again. So what this lab has determined or proved for us is the fact that regardless of the location of our ammeter, the current through a series circuit will stay the same, provided that the loads stay the same and my voltage source stays the same the whole way along. Okay, so that was lab 2-1, series circuits current relationships, and we'll discuss the observations and conclusions as a class. All right, thanks.